Let's look at a sound player that's cheap to purchase, easy to assemble, but has facilities to extend it if required. The DY SV17F, a mouthful. We've previously looked at other sound players. If you look at our WASAG website and search for light and sound, you'll find entries there, or you can look at our YouTube channel. So we won't go over them again, except to say that the commercial offerings are limited and expensive. Limited and very expensive. So we looked previously at DIY options, in particular the DF player, which uses an SD card to store the soundtracks. A previous edition of the Merck Journal showed how to program it and use it with an Arduino Nano. And we locally produced a PCB for that particular circuit. And it played multiple soundtracks. We built it into a box similar to the commercial offering, except much, much cheaper. And then we looked at how we could extend that particular module using a fob rather than push buttons, using an old Sky TV remote control for infrared control, and RFID. And these can continue over into the module we're going to look at now. And that is the baby brother of this module that we previously looked at. It's cheaper, but has the same facilities. Let's have a look. That's the chip with multiple pins. What do they do? Well, firstly, we run it from 5 volts. So you probably need to have a 5-volt regulator to power it from your 12-volt supply. It's got a micro USB socket to allow you to transfer files from your computer into the module. And then they're stored in a memory block built onto the PCB itself, as you can see there. It's got a 3.3 volt output, not input, output, because the module itself works on 3.3 volts internally. So all the pull-ups go to 3.3 rather than 5, for example. And then it's got 3 other connections that are used to set up how we want to operate the module. We'll look at that shortly. And then it's got 8 pins that can be used to pick between 8 different audio tracks. And how do we play those tracks? Well, it's got a built-in amplifier. It's got a built-in 5-watt amplifier, which can connect directly to a 4-ohm or 8-ohm loudspeaker. Or if you prefer, it's got digital to analog output, so you can connect directly to your own amplifier. The inputs can be a whole range of types: push buttons, switches, our Merg kits like the timer kit, the random kit, the sequencer kit, and so on. And as I said, the RFID, etc. So there's a wide range of devices can be used to play the tracks, to be the trigger. Now, I showed here the 3 pins that set up the mode, because you can make it play in different ways. Here is the connections for what's called mode 0. We're taking 10k resistors either to the 3.3 volt supply or to 0 volts, depending on the mode. In this case, as you'll see on the right, it's set up that way for mode 0. In that mode, it can play 8 tracks, 1 for each of the input pins. Once you bring a particular pin down to 0 volts, that track will start playing and will continue playing till it's finished, even if you release the pin. If you hold the pin down continuously, then that particular track will repeat over and over in a loop. That's probably the most common use for this module, I would think. But you've also got mode 1, a different set of connections for the resistors. They also have got 8 pins operating 8 tracks. The only difference is now that when you release the pin, it's no longer held down to 0 volts. Then immediately the track stops playing. That's the only difference. Do you want to play the track through to the end, or do you want to only play it as long as you hold the trigger down? So it depends your use. So for example, if you want to have the sound of wheels squealing on a tight radius, then you only want to play while the train is going round that part of the track. And as soon as you exit that part of the track, you want the squeal to stop. Then you would choose mode 1. If you want to play a station announcement when a train arrives, then you want to have mode 0, so you play the entire announcement. It's up to you. I've put together the parts to play the simple mode 0. A piece of Vero board, a 5 volt regulator with its associated capacitors. You'll see in the module with pins to mount it on to the strip board. Something like that. You'll see the 12 volts coming in through the 5 volt regulator and feeding the 5 volts in, but the 3 volts comes out to connect to resistors. And on the right hand side, as many push button switches as you require, or other devices connecting to the input pins. First of all, I've got the strip board and cut the tracks as shown there. I then turned it over, put in a couple of wire links, and then connected the various components as you see there. The capacitors and resistors can be connected either way around, of course, but the voltage regulator has to be fitted with the metal tab facing right, as you can see in that image. Then we have to prepare the module itself. There's 2 rows of header pins. On one of the rows, remove one of the pins, solder them in as you can see in the image, and then they plug straight in to the sockets. In my case, I've got header pins bottom left as a connection for the loudspeaker, and down the right hand side for connections to push buttons. And here's what it looks like when finished. If you want to play even more tracks, then you can go into combination mode. In this mode, we don't have 8 push buttons as the input to the module. Instead, with a microcontroller whose 8 output pins feed into those same pads. And depending on the binary pattern that appears on those 8 connections, the appropriate track will be played. So for example, if you put the binary pattern as this, we'll play track 1. If you change it to this, we play track 2. To this, we play track 3, and so on. And as you can see, all the selection pins are taken to 0 with the 10k resistors. And mode 1, as you'd expect, is the same, except that it stops playing when you release the trigger. That way, because you have 8 pins, you have a whole byte. A byte can handle 255 different tracks. And finally, if you know how to program a microcontroller to handle serial communications, then you can go into serial mode, which allows you to have up to 65,000 tracks. I doubt whether you can fit them all into a 4 megabyte memory, but it does expand it beyond the 255 if you have a need. So what we do, down the right hand side now, we don't have all the digital inputs. The bottom 2 now become the connections for the serial port. So you have to connect that to your microcontroller. The code that's suggested for it is simplicity itself. You include a special library, the DY player library. You initialize the player. You give the command to begin the player, set the volume, and then to play any one track, you simply say player.play specified, and in the brackets you put in the track number that you want to play. 1, track 10, track 50, whatever it happens to be. Of course, another benefit of serial mode or combination mode is that the microcontroller code can also be carrying out other activities such as animations and other automated control activities. And lastly, what about the sources of audio tracks to use? Well, of course, you can always record your own if you want personal pieces such as local station announcements, etc. Or there's a whole plethora of websites out there where you can download for free for personal use, as in the examples here. You'll see here that you can fit a surprising number of audio tracks even into 4 megabytes of memory. I've got almost a couple of dozen here with space to spare, and it includes some quite long background tracks. If you think you want to fit even more in, then of course you can take one of the options that has the micro SD card. And can I finish by pointing out that if you require it, you can get another version of this module called the SV17F, which works from 12 volts, which is convenient, but has got a 20 watt amplifier built in, which probably is far too much of an overkill for most model railway use. And of course, because of that, would require a much chunkier loudspeaker. So that's it. Are there any questions or comments or suggestions?